Now, something to note when you're solving these inequalities, like we were just looking at, solving the inequalities is going to be the same as when we solve equations because you have to undo the operation that's given to you. So in that last one, we had plus 7, so we subtracted 7 to undo that. But there's one difference that you need to remember. When you multiply or divide the side with the variable by a negative number, you must flip the inequality sign. So fill in that rule, and then we'll do a few examples to show you what that means. So in this first example, we have negative 5c is greater than or equal to 25. So it looks like a normal inequality. You need to just solve it. Right now we're multiplying c by negative 5. So to undo that, we would have to divide by negative 5. I'm going to do that on both sides. When I divide by negative 5 over here, I'm left with c. And when I divide by negative 5 on this side, I'm left with negative 5. But I'm going to think about what's that rule I just talked about. I'm dividing this side with the variable by a negative number. That means I'm going to take this inequality sign that right now says greater than or equal to, and I'm going to face it the other way, which now means I have c is less than or equal to negative 5. So I had to flip because of that dividing by a negative 5 there. So we divided by a negative, we flip the sign. Now we have to graph this. So first thing we want to do is find negative 5. That's going to need a closed circle because we have a less than or equal to sign here. So we close it. I'm going to put my L and my G here, and then we're going to decide which way to shade. The little side of our inequality sign is touching the variable, so I'm going to shade towards my L, and there's my graph. So now if we check this, we can even start back with our regular inequality that we started with. So I had negative 5, c is greater than or equal to 25. Now I shaded it over to the left, so I'm just going to pick a number that I shaded above. Like let's say if we use negative 8 here. I do negative 5 times negative 8 should be greater than or equal to 25. A negative times a negative is a positive, and 5 times 8 is 40. So that gets me 40 is greater than or equal to 25. That's true, so we know we shaded to the correct direction, and we solved this inequality correctly. Now let's try the next one. We have x is being divided by negative 2, less than or equal to negative 2. So right now x is being divided by a negative 2. We're going to do the opposite and multiply by negative 2 on both sides. When we do this, our negatives are going to, our multiplying and dividing are going to cancel each other out, so we're just left with x. Negative 2 times negative 2 is 4. But over here, we did have to multiply this side with the variable by a negative number. That's going to mean we need to flip our inequality sign. So instead of it saying less than or equal to, we're going to change it to say greater than or equal to. So now we need to go above our 4 and put a closed circle because we have greater than or equal to. I'm going to label my L and my G from least to greatest. And this time the big side of our inequality symbol is touching our variable. So I'll be shading towards the G for our greater numbers. And then let's go ahead and test this. So if I plug in a 5 here, I have my original inequality was x divided by negative 2 will be less than or equal to negative 2. If I plug in 5 here, I have 5 divided by negative 2 is less than or equal to negative 2. And when I do my division here, that's going to get me negative 2.5 is less than or equal to negative 2, and negative 2.5 is less than negative 2. So that is a true inequality there. We graphed to the correct direction, and we solved our inequality correctly. Now in our next example, we have x divided by 3 plus 2 is less than or equal to negative 1. So this is a two-step inequality that we need to get rid of the constant first. Right now we're adding 2, so we're going to subtract 2 to undo that. When that happens, our constants go away on this side, and we're just left with x divided by 3 is less than or equal to negative 3. All we did here was subtract. That does not change the sign of our variable. Now I have x divided by 3 is less than or equal to negative 3. So to undo this division by 3, I'm going to multiply by 3 on both sides. When I multiply by 3 over here, I'm left with x. On this side I have negative 3 times 3 is 9. Now I am multiplying by a negative on this side, but the side that I multiplied with on my variable, this was a positive number that I multiplied by. So our sign will not flip here. It's still going to be x is less than or equal to 9 here. So let's graph this. We're going to put our L and our G. We need, oh, I'm sorry, this should have been a negative 9. Negative times positive is a negative. So we need to put a closed circle on negative 9 here because we have less than or equal to. And the little side of our inequality is touching our variable. So we're going to shade to the L. And let's go ahead and test to make sure we did this correctly. So a number that would be to the left of negative 9 could have been, let's say, negative 12. And we'll use that as our test example. So if I put negative 12 divided by 3 plus 2 should be less than or equal to negative 1 here. Negative 12 divided by 3 gets us negative 4 plus 2. Negative 4 plus 2 gets us negative 2. And that is less than or equal to negative 1. It's less than negative 1, so that is true. So we solved and graphed that correctly. Now in our last example, we have one more two-step equation here. First thing we need to do is get rid of our constant on the side with the variable, so I'm going to add 1 to both sides. That leaves me with 6z is greater than or equal to negative 36. Now I'm multiplying z by 6, so I'm going to do the opposite and divide by 6. When I do that, I'm left with z, and then over here I have negative 6. Now again, we are dividing using a negative number here, but it wasn't on the side with the variable, so this will not flip their sign. And now we're just left with z is greater than or equal to negative 6. So we have negative 6 here. We're going to need a closed circle on it because we have that line underneath our inequality sign. We need our L and our G. And we have the big side of our inequality sign touching our variable, so we're going to be shading towards the G, towards the numbers that are bigger. And then let's go ahead and test one of these out. So our original equation was 6z minus 1 is greater than or equal to negative 37. And a number that we shaded in was negative 1 here. So let's do 6 times negative 1 minus 1 should be greater than or equal to negative 37. 6 times negative 1 is negative 6, minus 1 is going to get us negative 7. And negative 7 is greater than negative 36. It does fall to the right of negative 36 if you put them both on a number line, so that number will be bigger. And this is a true inequality graphed correctly. So just make sure that you're following the rules for when you're dividing or multiplying by a negative on the side with a variable, that you're flipping your inequality, and use the L and the G trick to help you graph these inequalities correctly. Always go back and check your work. You'll know you got an A before you even turn in your paper. Thanks for watching.